Hey, good morning, chemistry people, and welcome back to your post-spring break chemistry education. So, I think today we are just going to pick things up right where we left off, because we left off with acids and bases, right? Where you guys know that an acid produces hydrogen, a base produces hydroxide, and we learned about like two different kinds. The Arrhenius acid is just hydrogen, base is just hydroxide. We learned about Bronsted-Lowry, acid is a hydrogen donor, a base is a hydrogen acceptor. Learned a little bit about like some reactions, some basic things that they do, and like with an acid and metal, it makes hydrogen gas. An acid and base makes water and salt. Acid and base makes water and salt. Acid and base makes water and salt. Yeah. And then we learn how to, naming and stuff like that. So what we're going to dig into today is one very, very specific kind of acid-base reaction called a titration. And this is where, that's like the actual workhorse of acid-base stuff. It's where we have a sample that is unknown, like a tanker truck spills out on 87 and it was full of, I don't know, some kind of weird stuff. And it spilled all over the place. And we got to know, like, all right, how acidic is it? Like, do we need to, like, take care of it? Or can it just, like, let itself soak away? So we would scoop up an unknown sample and we put it in a beaker, right? Let's say, and we're just going to use litmus so that we know if the beaker has like acid or a base. And so for unknown, let's say for pretend this unknown thing is an acid, what we do is we make a base, and we're really careful about how we make it, so we know like exactly what the concentration is, and then we add base into that acid, and we use like the fact that there's one hydrogen for one hydroxide, and we can figure out how much acid was in that beaker based on how many hydroxide ions we had to pour into it to neutralize the solution. Now, how will we know if it's neutral? Well, we can use indicators, right? Just like we learned before, like they change color. And typically we use phenolphthalein. It goes from colorless to pink just at about 7. So it starts to change at about 7, and at 8, totally changed. So we typically use phenolphthalein. So if you're ready, or even if you're not, let's dig in. Like I said, the first thing we're going to talk about here is titrations. Now you might ask yourself, what is a tit? Hold on. Come here. Nope. Don't. Hold on. Don't do that. Bad kitty. Bad. Sorry. Cat on the computer. Sorry, cat on the computer does not go well. All right, so what we're gonna look at here, my friends, is this thing. Whoa, that's not what we're gonna look at. What is that? I don't want that. I want this. Titrations. We are going to look at titrations. And what is a titration, you may ask? Well, it is a method of calculating the concentration of an acid or base solution by neutralizing it with a solution of known concentration. So if we have an acid solution and we don't know its concentration, we add base that we make ourselves so we know what the concentration is until it's neutral. And then we just do some backwards calculations. If we have a base and we don't know the concentration of the base, we make an acid very carefully so that we know the concentration. We add it in there, neutralize, do some calculations. We'll get to the calculations in like just a minute, but for right now, let's just stick with. Why is that not working? Why would anything work? Anyway, let's keep going. Okay, so the way this works, my friends, is like I said, we're going to add a volume of acid or base of known concentration, right? So this is like something that we know the concentration of is what we're going to be adding into it. And we add it into a sample of unknown. And here's how this works, right? Now, you all remember that 1 mole of hydrogen will react with 1 mole of hydroxide and give us 1 mole of water. So we start with something that is acidic, and we add something that's basic, and we end up with something that is neutral. You guys get what I'm saying? So the way this works is one of these two, whether it's this one or this one, is going to be the unknown, and the other one, we know exactly the concentration. So if we have, for example, let's say if we had 5 moles, like we added 5 moles of acid, how many moles of hydroxide do we have? I'll like give you a minute to think about it. Yeah, 5 moles. Do you dig what I'm saying? Because it is a 1-to-1 ratio, right? So that's that. I mean, that's basically the math. The number of moles of hydrogen is exactly equal to the number of moles of hydroxide, and that is how it's going to help us out here. Why is my eraser not working for anything? Maybe because it's a pen, and they're like, too bad. I don't know. Who cares? Try one more time. I guess it's permanent pen. Let's. Well, if that's the case, then I'm using something good. Oh, okay. Here. There we go. See, that's way better there, isn't it? Okay. So here we go. Sorry, getting some of the stuff out of the way. Here's the equation. This is called your titration equation. That, again, you can find it in the back of your reference chart. Okay, so like this equation is not something that you're gonna have to like memorize, but there are a few little bit like details that we have to have about this. So you see how we say, I call this MA. This is molarity of your acid multiplied by the volume, and it will be equal to the molarity of your base. See, the B stands for base multiplied by the volume of your base. Now, couple of things here. Actually, specifically, 2 things where this can get difficult. The first thing that we got to keep in mind is that this molarity here that I'm talking about, this is not the molarity of just the acid. It is the molarity of your hydrogen ions. Do you guys get what I'm saying? This is what's important here, because the hydrogen ions are the things that are doing the reacting. Do you guys get what I'm saying? And the same thing, only like a little bit different, is over here, it is going to be the molarity of the hydroxide ions, not just the base. Here's where it gets weird. If we have a base, like, let's just do like good old sodium hydroxide, right? So what this means is 1 sodium hydroxide is going to give us, or it will equal 1 OH minus. Do you guys dig how that works? Right? Easy, right? Unless we switch it up. How about calcium hydroxide that has 2 hydroxides? Do you guys get what I'm saying? So what this means is if we have 1 calcium hydroxide, we will get 2 hydroxide ions. See how that could be tricky? Same thing with the acids over here. If we have good old hydrochloric acid, that's HCl, that's going to give us, well, wait, 1 HCl is going to give us 1 right? It's going to give us 1 hydrogen ion, and that is what acts in our neutralization reaction. Now, what's different is if we had 1 mole of phosphoric acid. Yeah, you guys see that right there? You guys see it? That right there, triprotic, brah. So if we have 1 H3PO4 or phosphoric acid, this is going to give us how many hydrogens? Yeah. See, that's the part that can get tricky. That's 1. Like the mono, di, tri, protic, and like the 1 or 2 or 3 like hydroxides. The other thing is that this volume, for right now, I'm gonna ask that everybody switches that volume to liters. Technically speaking, you don't need to, but for us to be safe, to make sure that you get it right every single time, I want this volume in liters, and I want this volume right here, no, blue, I want this volume right here to also be in liters. You guys get what I'm saying? So those are the 2 things you got to watch out for. Where are you going to find this equation? Reference charts, because you're not even scared. I know it. All right, so here's how this works. This thing that I'm bringing up here, right? Like this whole rigmarole right here. Just watch it. See how it works. If you're like, I don't get it, then fine. Just ignore it. So here's the thing. Here's how it works. This is your molarity. Let's go with, right? That gives us your concentration of your hydrogen ions. This is the volume of your acid right here. You guys dig what I'm saying? Now this one over here, this is the molarity of your base, and this is the volume of your base. Now if we make that, so the molarity is your concentration, which is measured in moles of hydrogen per liter, right? Moles per liter. That's what concentration is all about. Ooh, wait, let's go with this one. You guys understand what I'm saying? It is moles per liter. Now your volume is measured in liters. So if we take molarity, which is moles per liter, and we multiply it by liters, the liters here are going to cancel each other out, and we are left with moles of hydrogen. Same thing is happening over here with the hydroxide. The concentration of the hydroxide is moles of hydroxide per liter. If you multiply that by the volume, or like the number of liters you have, the liters cancel out, and you are left with moles of hydroxide. And we know that these two things right here, the moles of hydrogen and the moles of hydroxide, they have to be in a 1-to-1 ratio, right? Right, because 1H to 1OH. For good old high quality H2O. Do you guys get what I'm saying? So that's how this math, the whole math thing here works. So, for example, let's just burn through some problems here. Not all of them are going to need the full like titration equation. Just we got to put on our brain and remember that 1 hydrogen to 1 hydroxide, and if we do that, everything is going to work out magnifique, right? Okay, so word problems. Let's write out the variables first. So this question is how many moles of hydrogen? How many moles of hydrogen are needed to neutralize 2 moles of hydroxide? All right, well, we know that this is a 1-to-1 ratio, right? So if we have 2 moles of hydroxide, we will need yeah? All right, let's see if I'm right. Oh, I'm not. Let's see if I'm right. What is happening here today, people? Well, yeah, trust me, I'm right. It's 2. All right, moving on. All right, how many moles? This is just a bunch of example problems of like titrations and stuff, and we're just gonna pretend. Trust me, that's right. How many moles of hydro? Oh, here, let's go like this. Let's go with like gold glitter. How many moles of OH? Okay. Now remember, writing out the variables, including the one that you're looking for. It's just basic practice to turn a word problem back into a math problem because nobody likes word problems, right? So how many moles of hydroxide are needed to neutralize 200 milliliters? All right, so my volume, I'm going to take this decimal place. I'm going to move it 1, 2, 3 times to convert it straight to liters like right away, of 8 molar HCl. Okay, so I've got molarity of my acid equals 0.8 moles. Molarity. All right. So this one. I have 3 variables. Let me see if there's anything I can find here that might help me out. Let's see. Let's go down to stew stuff. Oh, look, I have it like saved right here in case I might need it someday. So I can just come down, scrolling all the way down. Where do I go for my equations? Oh yeah, right here. Wait, right there. Okay, so let's see which one helps us here. Probably not density. Probably not this one. See, because this is number of moles, gram form mass. Ain't helping nothing. Definitely not percent error, well, concentration. Here's the thing. Look at this. This might be a thing. I don't know. Let's check it out. Parts per million. Molarity is moles and liter. So this has molarity, moles, and liters. Molarity, moles, and liters. I think we have our equation. So our equation is going to be molarity equals moles per liter, right? So this is a question that's under the title of titrations, but here we are using a concentration equation, and that is why I really need you to do this. Like, you guys got to write out these variables so that you are guided to the correct equation, because this is what happens all the time. People are like, like, you're trained in math to, like, here's your equation, here's your equation. It's not the way it works in science. The way it works in science is, here are your variables, what equation you're going to use. So after we know our equation, it is going to be just a matter of plug and chug. So our molarity is 0.8 equals, well, the number of moles, that's going to be my, I don't know, but I'm going to figure it out in just a minute, and my volume is 0.2. So x equals 0.16. I don't know. Can you guys do math in your head? I don't know. Yeah, I should do this for a living. Should totally. Oh, actually, I'm going to do 0.6 moles of OH. Yeah. Super easy, right? Hold on tight. All right. Ooh, look at this. One of the things I want you guys to start doing, let's do it purple here. If I needed to see this right here, this is my vocab word, right? Watch for the vocab words in the question. It's going to make a huge difference for, like, how we go about solving these problems. So if it's saying neutralize, I know right away it's going to be hydrogen and hydroxide 1-to-1 ratio, right? All right, let's go. Let's write out our value. Let's write out our variables. All right, so we're given right up here 150 mils of 3 molar NaOH. See my OH right here? That's going to, wait, let's go up here. Let's see if we can color code this. That's my NaOH. That's my base, right? Because OH. So I'm going to take this and go 1, 2, 3. Volume of my base is equal to 0.150. Right? And here, here's my molarity. The molarity of my base is 3.0. Right? Got it right there. Okay. How many moles of hydrogen would we need? So I need moles equals quite. All right. See, now this word right here, this is saying neutralization, right? So I was right automatically thinking that we're going to need that neutralization reaction equation, right? Well, silly you, silly me. At least we wrote out the variables, because that's what really counts, right? So here's what it's going to be: volume, molarity, and moles. I'm gonna ask this one more time. What equation uses volume, molarity, and moles? Volume, molarity, moles. It's going to be your molarity equation from the back of your reference chart. Sweet. Let's go check it out. So, molarity is going to equal to moles per liter. So that'll be 3.0 equals X over 0.1. And aren't we so smart that we, like, switched it right over to liters before we even got started? So X equals there. Super easy, right? You guys could do this if you write out your variables every time and then choose your equation based on that. Like, you'll get it'll go really easy for you. Okay, so I think this might be it now. It's a hunch, but what do you guys want to do? Space or rainbow? Let's do space. I don't think we've had enough space pen yet. Okay, so the question is, how many milliliters? All right, this is going to be my big question mark right here. How many milliliters of 1.0 molar HCl, oh, that's a thing, are needed to neutralize 200 mils of 2 molar NaOH? All right, so first things first. I got one hydrogen. I got one hydroxide. These things are going to be straightforward and easy, right? Awesome. So let's write out the variables here. How many milliliters? So that's going to be V. All right, so of my acid. So this is going to be VA equals, I don't know yet, but I'm going to find out. The molarity of my acid, it says right there, is 1.0 molar. I'll put that there. So, are needed to neutralize. Oh, no. One, two, three. Yeah, okay. Much better. So the volume of my base is going to be 0.200, and the molarity of my base is going to be equal to 2.0. You dig? Now, if I had the volume of an acid, I have the mass of an acid, I have the volume of a base, and the molarity, acid base. Yeah. Okay. So, that equals mub vub. That equals mub vub. That mub vub. So yeah, what is that? What is that from? Bam. Titration equation right there. And if you look right here, see where it says right here, molarity of H, molarity of the hydrogen ion. It does not say molarity of the acid. It does not say molarity of the base. It's saying molarity of the hydrogen ion. Same with over here, molarity of the hydroxide ion, because those are the things doing the stuff. And so that's the stuff we care about. So it's going to be a simple plug and chug here. It's going to be 1.0 times X is going to equal 2.0 times 0.2. Let me calculate this, because I'm gonna say that and then it's gonna be wrong, and then I'm right. Oh my god, look, it's like I paid attention to do math. All right, you guys follow how to do the titration equation? Now that was an easy one, man. That was easy for you guys. It was a starter one because look, right? We got one OH, we got one H, one hydroxide, one hydrogen. I have a feeling it might get a little more spicy later. Let's just see what we got right here. All right. How much, that's going to be your volume of 0.1 molar HCl is needed to neutralize 2 liters of 3 molar KOH. Nice. I've got an acid. I've got a base, monoprotic, monohydroxyl. It's great. So how much acid? That means the volume of my acid in this one is my question mark. I've got the molarity of my acid is 0.1. The volume of my base, straight up 2.0 liters or 0.2 liters. That's awesome. And the molarity, of my base is 0.3. It's like you can already tell what equation we're going to use, right? I've got volume and concentration for an acid, volume and concentration for a base. That is classic MAVA equals mub, vub, plug, and chug. 0.1. This is my X. You can write X or B. I don't care what you do, whatever works for you. The molarity of my base is 0.3, and the volume of my base is 0.2. So, how are we going to do this? There's a couple ways to do it. What I like to do when it gets messy like this, I'm going to throw this in there for you guys, is I like to get my unknown variable all by itself. So to get this one all by itself, I'm going to have to divide both sides by 0.1, right? So if I do that, it'll be divided by 0.1. This will be divided by 0.1. These guys cancel out. I'm left with VA. The volume of my acid is equal to 0.3 times 0.2 divided by 0.1. 0.3 times 0.2 divided by 0.1. Oops. Just like that. We good? Yeah, I mean, you guys see how easy this is? Man, if you write out the variables, smooth sailing the whole way through, then it's just like basic algebra. Easy, right? Okay, so now we're going to turn it up a notch. This is where it's going to start to get a little bit tricky, where we have polyprotic acids and polyhydroxy bases. This is where we have more than one hydrogen and more than one hydroxide. But it'll be pretty easy to see. You just have to look for those little teeny those little teeny subscript thingies, right? Because you've been doing that this whole time for a reason. All right, let's do an example. What is the concentration of or a hydrochloric acid solution of 3 mils if the acid is neutralized with 50 mils of 3 molar CaOH, calcium hydroxide? My friends, you see that right there as the major problem, right? So we have, what is the concentration? That's your question mark of HCl. That right there, that's the volume of your acid. All right, because we're going to go 1, 2, 3. It'll be 0.030, right? Of this acid is neutralized with 1, 2, 3. So it would be 0.050 liters. And right there, that is the molarity of your base. But we have to correct here. We got to correct for this thing, okay? So what we do, it's super easy, guys. You take this number 2, this little subscript, and you put it right in front of the concentration of whatever it is. In this case, it's the base, so I'm going to put it 2 in front of the concentration of the base. Does that make sense? Because what that means is, so what we're correcting for is this thing where one calcium hydroxide is equivalent to, or yields, or makes 2 hydroxide ions. So for every one of these things, for every one of this, you get 2 of your hydroxides. So whatever the concentration is of this, whatever it is, you just multiply it by 2 to get what this concentration actually is. So what it looks like in the equation is you just take the subscript and put it in front of the concentration and math just like you would any other day, right? So here we go. Oh, there it is right there. You guys get what I'm saying? So it turns out to be, like the whole equation is going to be, I'm going to write it down here, or maybe over here. Let's shrink this down just a snitch. This will be, that's really stupid. Come on, man. Give me a happy medium here. 2 times 3 and 0.5 divided by, right, because I'm going to divide both sides by this to get the MA by itself. And this is how we're going to do the math, which I don't really know, so I'm going to calculate it out. 2 times 3 times 0.05. Dropped it. What does it say? It says 10. Am I right? I don't know. You tell me, man. I think I'm right. I've done mathing. All right. Let's put her to the test here, my friends. How many milliliters? Let's see here. Well, actually, you know what? Let's go like this. Let's go to highlighting. How many milliliters? That is going to be my big fat question mark of 0.5 molar H2SO4. Oh, you see that? See that little subscript? Okay, keep that in mind. Is needed to neutralize 100 mils of a 2.5 molar KOH. All right, so let's see what we got here for variables. How many milliliters of my acid? So the volume of my acid equals my question mark. The molarity of my acid is 0.5. The volume of my base, 1, 2, 3, is going to be 0.1. And the molarity of my base is going to be 2.5. Right? So something I need to keep in mind, remember, do not forget that this is going to need, this, do it in gold sparkles. You need to remember this, right? Can't forget that when we do our equations. So when we do our equation, we have, it looks like it's going to be a MAV, VAV, MUB, VUB. So the MA is 0.5. And I'm going to put a 2 out in front of it, right? Because of this, right? That's where that comes from. Times that equals MUB, the molarity of the base, times the volume of the base, which in this case we're going to put as 0.1 liters. You guys get? So to do this all out, I don't know if this eraser works yet. Eraser's just not working for me today, guys. It's like permanent marker pen today. Yeah, well, I'm okay. So what we're gonna do is I'm gonna divide both sides by 2 times 0.5. See how this works out? Basic algebra, cross multiply, I don't know what you guys call it. I'm left with the volume of my acid will be equal to 2.5 times, 2.5 times 0.1 divided by 2 times 0.5. Is that right? Did I get it right? Because this one's going to be marked wrong. I'll give you a minute. I'll give you a minute. Here, maybe I'll give you like a galactic hint with my like, I don't know, my space pen. Yeah, I can't do that, man. If that's for milliliters, this is going to have to be changed to 250 milliliters. And then you can call it done. Picking up what I'm putting down. Riding away. Feeling the flow. Digging the groove. Smell what I'm stepping in? That's pretty bad because my dog's huge. You don't want to smell that. Hey! We made it! That's great. And you're welcome. There will only be 2 homework assignments, one called Titrations. It's the multiple choice one. You are going to be using the exact same equations we used today. Sometimes it's going to be the molarity equation. Sometimes it's going to be the MAV, VAV, MUB, VUB. And sometimes it's just going to be a 1-to-1 ratio of hydrogen to hydroxide. How do you know which one to use? You write down the variables. Right? Like I've been saying that since I don't even know when. You write down the variables. When you're done that, and I would like for you to start with this one, the multiple choice one, because that kind of goes all over the place for you, and then do the Titrations word problems in your homework packet, and I will post them at the up with this Google Classroom assignment. It's good to see you guys again. Hope you're ready to go. I'm feeling really good. The sun is shining. I'm finally all better. I'm feeling good. So yeah, get at it. Oh, also, just to kind of clean things up, I'm going to make these things due a little sooner than they have been in the past because y'all wait to the very last minute and you're driving me crazy with that. So